Okay. Good afternoon, guys. Last time we discussed electrodynamics. Okay, so natapos natin yung electrodynamics and on the note na whenever the Maxwell's equations are in vacuum, nakita natin na yung electromagnetic fields mo ay waves. Okay, with the speed of light as the wave speed. Okay? Yeah. Amazing. So ayun yung nakita natin last time. And so today, tutuloy natin ang discussion natin. Discuss din pala natin last time yung chapter 8. Yung chapter 8 ay kinuha lang natin ay yung pointing vector or the pointing theorem, which states that the power is given by this. Okay? So that the change in the total, of course, the total work plus a term na yung energy that leaks out of the surface, yung surface in question. Okay, so may power due to that. All right. So we now continue our discussions on electromagnetic waves. Okay? Okay. Ang electromagnetic waves, talakayin muna natin kung ano yung mga waves. Paano ba natin sinusulat ang waves? Okay? So waves can be mathematically represented by a function. Siyempre, yung function mo f should be a function of space and time. This tells you kung nasaan na yung wave mo and kung anong oras siya nandun. Okay? So yung wave mo always in motion, and you can see that from here na yung f of z0 can be represented at a later time, f of z t. Tapos yung distance between those two waves would be, of course, v times t. Okay? So in essence, you can write your wave as like this, and then you can always go back in time to write it down as like this. Okay? So ginawa mo lang na 0 yung time, tapos syempre babawasan mo yung kung nasa yung pwesto niya by amount of vt. Okay? Kasi nakita natin dito, naging at a distance vt, ito na yung function mo. So i-revert back mo siya in time, you'll have this equation. Okay? Kung gusto mong eliminate yung second, plug in na t is equal to 0. Okay? So ayan, repetitive yung waves mo. You have that. And we know that waves are guided by the wave equation. Okay? So whatever this equation spews out, ang lalabas doon would be a wave. Okay? So kung ano man solution na mahanap mo kay f, dito sa wave equation na to, then that is a wave. Now you can generalize those waves into two terms, once in the right and once in the left. Okay, papakita natin yan mamaya kung bakit ba yun yung mga ano natin. Okay? The most common waves we know is the sinusoidal waves. Okay. Weird, no? Sinusoidal pero cosine gamit. Pero same lang yung ano. For convenience lang yung cosine. Kasi when you plug in the cosine 0, pag nag-0 yung nasa origin ka, then this would be 1. So nasa maximum yung maximum ng wave nasa origin mo. Okay? So kaya siya cosine yung ginagamit for convenience lang. Pero itong shape ay same for sinusoidal waves. Okay, sine yung wave. Okay? So ayun yung mga common na, ayun yung usual na waves natin. Okay, so ngayon hihimayin natin kung ano yung mga parts nitong wave mo. Okay? So yung delta here is a constant. This is a phase factor, a phase constant. Okay. Basta phase siya. Okay, phase. Okay. Kaya siya nandyan, just to account for ito lang yung nag-account do sa plus or minus 2 pi mo or whatever that is. Kasi di ba ang cosine theta, equal lang yan sa cosine theta plus 2 pi. Okay? So in essence, yung equal lang din to sa cosine theta plus 4 pi and so on and so forth. Bale, ang ibig sabihin lang dito ng delta, ayun, siya yung nag-account din sa constant na yan. Okay? Okay. Now, si z ay function of space and si t ay function of time. Si v dito ay velocity and k is the wave number. The wave number is related to the wavelength, which is lambda here. Okay guys, yung mga math na gagawin natin today, medyo paulit-ulit siya and nakaka-confuse siya on the pagpaulit-ulit mo. So I want you guys, kung sino man na sumasabay sa akin ngayon mag-solve ng bagay-bagay, is I invite you to write down this bad boys. Okay? For later on. Para sa mga purposes natin later. Okay? Okay. So, ito, si wavelength, yung lambda, then k is the wave number. Okay? So, they are both related by this equation. And then the period t is given by, di ba, ang usual equation natin dito is v is equal to lambda f. Yung f mo ay frequency, pero papalitan mo siya ngayon ng sorry. Tama. V is equal to lambda f. Then you want it to be, yung f mo ay 1 over t. Lambda over time. Or the period. Okay. So length over time. Di ba? Wavelength over time. Makes sense, di ba? Makes sense. Okay. And then lambda mo is just, kung relate natin siya sa wave number, and then this would be 2 pi over k t. Okay. So, ayan. Ito siya. Okay. Si v dito ay speed, again, speed ng wave mo. And then you have this relation for your period. Okay? Makes sense naman, di ba? Kasi ang velocity mo ay meters per second. So, dapat length over time siya. So, yan. Ay factor nyo na lang para lumabas to. Okay? So, you have this. And then we have, ayokong gamitin to, pero ito yung ginagamit ni Griffiths. Ito ay nu. Greek letter nu. Okay? Pero feel ko naman alam nyo na yung mga Greek letters natin dahil sa dami ng variant ng COVID. Okay? So, bago mag-Omicron, may nu. Ayan, so, ito, bakit kasi niya letter V din, no, kalito. So, ang ginagamit ko, F for frequency, para intuitive. Okay? So, yung F mo can be written down as, sabi ko nga, 1 over the period. So, 1 over t. Then you plug in here. Okay, so F can be, ayan, sinulat niya na pala. Ito pala yung sinasabi ko kanina. Okay, so ayan. Okay. And then we have another one here, which is your angular frequency. So angular frequency is just 2 pi f. Or 2 pi nu, kung gusto niyo yung connotation ni Griffiths. Okay, and then you can write this down as kv in terms of the wave number and speed. Okay, so when we simplify this, multiply natin yung k papasok sa loob. We have kz. We have this, kz. Then minus kvt. So, makukuha natin itong usual representation of waves natin as kz minus omega t plus your phase constant. Okay? Okay. Kaya kung ayan, ulitin ko lang, no, itong yung matulis na, oops, na nangyari. Sorry. Wala. Yan. Naglo ko. Okay, so yung matulis na letter V ay nu, which is yung frequency, pero ayokong gamitin yun. So, F gagamitin ko. Okay? Nakakalito lang kasi may F of something dito. Pero mamaya hindi naman natin yung gagamitin, yung mga F of F. Okay? Dahil yung mga waves natin would be electric field and magnetic field. So, E tsaka B yung gagamitin natin mamaya. Okay? Ito na yung ito na yung equation mo for your wave. Okay? So, yung unang term would determine kung saan papunta yung saan papunta uh, yung wave mo. So, positive KZ dapat papunta yan to the right and negative KZ would be to the left. Alright? Okay. Tawag dito. What else? Kung nagtataka kayo, no, yung mga early physics courses nyo, bakit ba omega tin dito? Ba't hindi na lang frequency, di ba? So, ayan, dyan siya nanggaling. Kaya siya omega dito. Okay? Dahil, nakita nga natin, dahil KVT siya. KVT. So, magiging omega siya. Alright. So, this is your, this is your wave. How you represent a wave mathematically. Now, ayaw natin ng mahirap mag-derivative ng cosine. Mamaya magiging tangent pa yan, etc. etc. Pag dumami yung mga terms. So now we discuss complex waves dahil mas madali itong complex waves. Okay? So we recall the Euler's formula. Euler's formula. Sige, kaya ko magsulat. Formula. Okay, so ito ay itong bad boy. Okay. So we have this equation, e raised to I theta is just your cosine theta plus I sine theta. Then you can use this to create waves. Okay. So the general form of the waves in the complex plane, complex numbers would be this F tilde. F tilde mo. Tilde ay yung ganun. F tilde ZT. And you can express this as A tilde. Tapos ayun nga, e raised to I theta. Pero yung theta mo this time is just yung specs ng wave, di ba? Okay, kz minus omega t. Alright? Okay. So, nasan na yung phase factor? So, yung phase factor inabsorb ni constant. Dahil kung susulat natin ito explicitly, we can write this down as e raised to I kz minus I omega t plus I delta. Okay? Then si I delta, pwede mo siyang ihiwalay, di ba? Okay, I theta na lang to guys, parang diyan. Tapos, pwede siyang hiwalay dito. Okay? And then, pwede mo itong i-absorb dahil constant lang din to. Pwede mo na siyang i-absorb sa A. So, we have this definition for the complex amplitude. Okay? So, hindi ko pa nasabi no amplitude pala yan. Pero feel ko naman gets naman nating lahat na ito ay amplitude. Okay? Amplitude yung constant outside your cosine. Siyempre, ito ay complex waves, no? So hindi siya useful in real life. So what you get is the real part of this F tilde to get the real waves kung ano yung importante sa buhay natin. Okay? So you have that. Guys, I assume na marunong kayo kumuha ng real parts or imaginary parts ng complex numbers. So kung naalala nyo pa yung 1, 1, 2 nyo. Okay, kuwari meron tayong Z na merong imaginary. So si Z ay imaginary, A plus IB. Then the real part of Z is A. Then the imaginary part of Z is B. Okay? Okay. Dali, di ba? Kung ininitpick mo lang. Okay. Now, yung waves mo, you can combine them to produce a much weirder wave. Okay? So, may mga waves tayo na kakaiba tulad ng yung square wave, pag ganyan siya. Siyempre, how do you do that? So, this is a superposition of a lot of waves. Ay, sorry. Nawala siya lahat. Okay. Yung mga ganyang wave, yung result niyan ay superposition ng waves. So, in general, you can always write down your waves as an integral. Okay, integral, that is counting your wave numbers. Okay. So, nagde-describe pa lang ako ng mga wave na wala pa tayo talagang computation na ginagawa. So, you have this your complex wave. It should be, kung gusto mo siya in a general form, okay? Then, this should be a sum. Yung f tilde mo, dapat sum siya ng mga waves. So, dapat, ayan, integral para maging mas generalized. As over, yung counting mo over the wave number. Okay. Okay? So that is your waves. So for every wave, sir, ano po yung wave number? Para saan po yun? Ang wave number ay yung wave number tells you something about the wavelength of the wave. Okay, kasi si wave number ay 2 pi over lambda. Okay? Okay. So basically, sinasum mo to all over wavelengths. Pero mas madali yung K. Okay ba? Okay, okay. So you have that. What else am I forgetting about K? Okay, wait lang. Okay, wala pa. Okay. Now, sige, mag-solve na tayo ngayon. Paano ba gumagana itong mga waves natin? Suppose meron kang string. Okay, so drawing tayo ng string dito. Meron string that stretches out from negative infinity to infinity. And then, dalawang string meron ka. Yung green and yung not dot joins them. Okay? So, meron kang dalawang string, blue and red. Then, the green would be the knot, yung tali or buhol na nagdidikit sa kanilang dalawa. Okay? Okay. Now, suppose, pinagayway mo yung string mo, syempre, may mabubuo kang waves. Okay? Gawin natin regular. Okay. So, now, i-assume lang natin na regular yung waves mo. Hindi siya nagdi-diminish. Yan. Mukha lang siya nagdi-diminish sa drawing ko, guys. Pero wala pa tayo sa point na yun. So, ang system lang natin very simple. No? Meron kang wave na dumadaloy basta sa mga strings mo. Okay? So, when it reaches that knot, ang mangyayari, tutuloy siya sa kabila, which is intuitive, di ba? Siyempre, weird naman kung di siya tumuloy sa kabila. Pero may cases na hindi siya tumutuloy sa kabila. Okay? And then, some of it will be reflected back. So, meron tayong tatlong waves actually. Okay? So, meron pa isang ganun. Okay, may incoming, may reflected, then may transmitted. Okay, now we set up our equation. Suppose na guys, ang direction ng propagation ko ay z. Okay, z. So this is, sabihin natin z is equal to 0. Green na lang, mas maganda. Okay? Yan. Para yung mga waves natin. Hindi ko pala nasabi, no, yung variable mo dito is kung saan siyang direction gumagalaw. Medyo intuitive naman yun kasi pinakita ko dito na ayan, yung z mo, yung direction of propagation niya. Okay, so kung ano yung variable na nandun sa kanya, dun siya dumadaloy. Okay. Okay, going back. So meron tayong collection na tatlong waves that would be written down in a single function we call f tilde. Okay, so yung f tilde mo collection lang yan ng collection lang ng waves mo. So, ang gusto natin malaman kung paano yung nare-reflect and nare-transmit once you do a wave between two different objects. Okay? So, yun yung goal natin. Tingnan natin yun. On the left-hand side, z less than 0, you'll have two waves. Yung one going to the right and one going to the left. Kasi yung one going to the right would be the initial wave or the incident wave. Then the wave to the left would be your reflected wave. Okay, gets ba yun? Gets ba yun? So you have these two terms. AI for your incident. So may mga tilde sila dahil complex numbers sila. No? In-assume natin complex numbers sila. Okay? So you have this. For the first term, the incident wave, we have this. And then the reflected wave is given by this. Pansinin nyo yung negative sign dito. This tells me that it is going to the negative z direction. Okay? And then on the right-hand side, for z greater than 0, you have one wave, which is yung transmitted lang. So you write it down. You have this AT. Okay. Para sa transmitted. Then, okay, pansinin natin yung mga K. Bakit same yung K dito? Kasi yung K would be determined sa properties ng string mo or ng wave mo. Okay? So, in the left, same sila. Dahil nandito sila sa left, same string sila, red. And then yung sa right-hand side mo, K2 na siya kasi this is a different string. Okay? Have that. And then now, what we're gonna do is to apply the continuity equation. So, dapat yung mga waves mo, continuous sila dapat at z is equal to 0. Weird naman, di ba? Kasi pag hindi sila continuous, ibig sabihin, hindi sila magkadikit. hindi mo kadikit yung string na dalawa. So, walang transmission na magaganap. Unless mag-teleport yung mga waves. Pero, ayun. Huwag natin problemahin yung mga ganun bagay. Okay? So, you have this. Try natin, no? So, lagay natin yung dapat yung at z is equal to 0, equal dapat yung mga terms. So, you have AI. Sulat natin. AI. E raised to 0 na yung sorry, but naglagay ako ng negative sign. 0 na yung mga z mo. Okay, kasi nasa z is equal to 0 tayo. So, matitira ay mga negative I omega t. So, we have negative I omega t. And then, plus your AR, reflected term, e raised negative I omega t. If same lang po yung K, so nung incident at reflected, edi same lang po yung wavelength nila. Yes. Yes. Good observation, yes. Pero pwede magbago yung constants nila. Okay? So, pwede mo siyang ma-distinguish as different waves. Okay, good observation. 80. So, ina-apply lang natin yung boundary condition na continuity, no? Okay, so you have that. So, makakancel lang yung mga exponential terms and you'll be left with AI plus AR plus is equal to 80. Okay? And then, apply natin tong boundary condition na to. Okay. Ito ay saan to nang gagaling. Okay. So, itong boundary condition mo, pwede siya magbago, no? Hindi ito lagi yung boundary condition mo. So, yung boundary condition for this, nag-arise lang siya dahil sa may assumption tayo na ginagawa dito sa dalawang string mo. So, dapat yung dalawang string mo, medyo magkalapit sila ng weight. Okay? Para pag nag-wave sila, zoom in lang natin. Okay. Pag nag-wave sila, tutuloy lang yung wave mo. Okay? Kasi kung wari masyadong mabigat yung blue, ang mangyayari, wari ang wave mo, tapos sabihin natin sobrang hina nung epekto nun sa kabilang string dahil mabigat nga siya. Oops. So, mahina lang yung wave. So, itong linya dito, yung slope dito, hindi nagtutugma pag masyadong mabigat yung string sa kanan. Okay? So, we assume na medyo same lang yung ano dapat nila. Yung bigat ng ano nila. Okay? So, you have that. Kunin natin derivative. Okay, mabilisan na lang. Kaya natin to, no? Pag alam naman natin derivative ng e raised to kx, di ba? E raised to kx, derivative nito with respect to x. Di ba nasa mga memes to? Di sila tinatablan ng differentiation. So, bababa lang yung constant, no? Okay. Okay. So, yung si t hindi sila maapektuhan dahil z nga lang yung derivative mo. So, pag din-derivative natin to, ang lalabas would be, bababa lang si ki, which is here apparently, and then dito, bababa si negative ki. Tama ba? Which is here apparently. Negative ki. Okay? And then on the right-hand side, for the transmitted part, bababa lang si K2. Okay. Which is, kita naman natin. And then, ang mangyayari, matitira ulit yung mga e raised to I omega t mo kasi mag-zero yung z mo, di ba? Plug in mo si zero dito. Okay? Parang katulad lang din ito. Kanina matitira, di ba? Pag pinlug in mo na z is equal to 0. So definitely, ito yung makukuha mong equation. Okay? Okay. So now, meron tayong dalawang equation, meron tayong dalawang unknown. So, tapos na tayo sa problema natin. Yung AI mo, given siya. Okay? Hindi mo lang alam yung AR at AT. Okay? So, you solve for AR and AT. Okay? So, pwede mo agad eliminate try natin, si AT. So, K1, A1 minus AR, KI pala yun, sorry, must be equal to, di ba K2 AT? Pero yung 80 mo, ito lang yan. Solve mo agad si AI plus AR. Okay? Dali, di ba? So now you can solve for AR in terms of AI. A1, A1, AI. Sorry. Nalilito talaga ako dun. Daming notation. Tapos K1, K2, AI plus K2, AR. Okay. And then you solve for AR. So dapat yung denominator K2 minus K2 minus joke. K2 plus K1 pala. Yung denominator. Tapos ang numerator would be K2 minus K1. Okay? So now we go back. Ano ba yung K in terms of other functions? Okay, so we have this equation. So omega kv. Okay. Okay, so now we have your AR. Hindi ko na solve lahat guys. AR, tapos ang nasa taas na term would be K2 minus AI, okay. Naka-K pa siya. Ang pangit talaga ng K. Ay, gumalaw nung screen ko. Sorry. Okay, so yung denominator, sure tayo then na K2 plus K1. And then, lipat lang natin. So K1 minus K2. Okay? Okay. We have this, and then double check ko lang sa notes ko. Okay, tama naman tayo. K1 minus K2 tapos AI. Okay. So, ganun lang, no? Ganun lang gagawin mo para ma-produce din si AT in terms of AI. Okay? So, i-eliminate mo naman si AR in that process. Pero, tingnan muna natin tong AR. Then, we can actually write things down in terms of K1, in terms of velocities. Okay? Ang velocity natin would be given by, ano natin dito? Omega is equal to KV. Okay? So, omega is the same for everything. Okay? Since si omega ay defined by frequency. Tama? And the frequency is your identification number for waves, for light. Diba? Kasi frequency doesn't change. Kasi ayun yung bit-bit niyang energy. Kung familiar na kayo dun sa quantum mech nyo. Na dapat E is equal to HF, diba? So, dapat yung frequency yung nagde-define ng mga waves mo. So, we have omega to be constant for all everything. And we know omega is also written as KV. So, you have K1 V1 must be also equal to K2 V2. Okay? Okay. Alright. So, from here, pwede mo nang kunin yung mga relation mo. K1 is just K2 V2 over V1. Then K2 is just K1 V1 over V2. Okay? Okay. So, pangit yung gawin. Pangit gawin yun. So, gawin na lang natin na K1 over K2. Mas madali ito. K1 over K2 is equal to V2 over V1. Okay? Then I factor out K2 here. K2 over K2. So this one is K1 over K2 minus 1. Then 1 plus K1 over K2. Okay, tama ba yun? Then this one would cancel out. Makikita na natin na madali yung ginawa natin dito. Kasi K1 over K2 is just V2 over V1. So this is V2 over V1 minus 1 over 1 plus V2 over V1, which becomes V2 minus V1 over V1 plus V2. Okay, so you have that. Okay, kita mo yun, no? Yun yung lumabas doon. Okay, lumabas dito. Now, pwede natin isulat yung A tilde natin, di ba, as a function of the expanded form na. So, yung expanded form nito, given kanina, na yun ay ito, AEI delta. AEI delta R, AEI delta I. Okay, so if they are in phase, so equal lang yung mga delta R, delta I mo, delta T, then magre-reduce itong term na to into this term. Okay? Sir, ba't sa slide nagbago po yung placement ng V1 sa... Ito. Ito yung pangatlo. Tama ba? Ito ba yung tinatanong mo? Okay. Wala pa tayo dyan. Okay. Kaya siya nagpapaulit kasi explain ko. Okay. So, may assumptions tayo for this, guys, no? So, para ma-produce yung dalawang to, gagawin mo, Mag-assume ka, kasi ito talaga yung final answer mo. Pero, ayun nga, hindi pa naman sa atin given yung delta R at delta I. Mag-assume muna tayo mga bagay-bagay. Assume natin na in phase ngayon sila delta R, delta I, at delta T. Ang mangyayari, magka-cancel out lang sila and you'll be given, meron ka makukuha ang ganito. Okay? Kasi magka-cancel out lang sila eh, di ba? So, ito yung makukuha mo. Alright? So, that is one case. However, if the second string is much heavier, ang mangyayari is hindi magiging in phase tong dalawang to. Okay? If by any chance na yung phase difference is 180 degrees, so delta R plus pi must be equal to delta I equal to delta T. Kuwari ito yung case mo. Ang mangyayari pag pin-login mo sila dyan, ang lalabas dun sa, ang mangyayari lang is magkakaroon ka ng negative factor sign dito. So, kaya siya nag-switch. Kasi, transmitted, unaffected siya. Ano implication nito? Pag tinignan mo sa wave, meron kang ganyan. Okay, so, yan yung not. Pag na-reflect na siya, magiging kabaliktaran siya. Sa lubungin niya, kabaliktaran. Okay? Okay, so you have that. Now, what happens kapag, amazingly, tingnan nyo, what happens kapag yung V2 mo is 0? Ibig sabihin, hindi gumalaw yung second string. So, lahat nung ang mangyayari, okay, pag hindi gumalaw yung second string, ibig sabihin, mas mabigat siya. Tama ba? So, gagamitin natin yung pangalawang equation. And when that happens, V2 is equal to 0. This is 0. So, nothing is transmitted. Nothing is transmitted. Then, V2, AR is equal to AI. Okay? So, lahat nung make sense, di ba? Na kapag hindi siya nakapag-transmit, dapat lahat i-reflect niya. Okay? Amazing, di ba? Okay, so you have that. Okay. So now, medyo may glimpse na tayo kung anong gagawin natin. Paulit-ulit mamaya. Puro ganito yung gagawin natin. So that's what happens when waves passes through one medium to another. Pero yung medium natin dito, strings pa lang. Wala pa yung legit na medium. Okay? Now, let's talk about waves. Waves again. Yung waves mo, may polarization siya. Guys, ibang polarization to, no? Sa polarization natin sa electric field. Okay? Iba siya doon sa mga bound charges mo. Okay? Iba to. Okay? Yung polarization basically tells you where the wave is aligned. Okay? So, may vertical polarization ka. Ibig sabihin nun, naka-align si wave mo sa x-axis. Okay, ito yung coordinate system guys ha. Tingnan nyo. Yung propagation mo would still be z. And kapag naka-align siya sa x, ibig sabihin vertically polarized yung wave. Horizontal polarization, ibig sabihin nakatutok siya sa y. Siyempre may arbitrary rin tayong polarization. So meron tayong polarization vector n hat. Yan, n hat. Saan nakatutok yung wave mo. Okay? So, sa n hat siya. Mahirap lang imagine dito. So, itong mga tinuturo ko dito, sila yung mga nandun sa likod, at itong dalawang to, mas malapit sa atin. Then, you can define that polarization vector by cosine theta plus sine theta. Okay? X hat, y hat. So, pwede nyo imaginein, no, yung arbitrary na polarization n hat would be a summation of two vertically and horizontally polarized waves. Okay? Pwede niyo imagine yun. Okay. So we have that. So ayan, pag sinabing polarization ng waves, ayun lang kung saan lang siya nakatutok. Okay? Nothing complex about that. Okay, let me check this. Okay. Sige. Tuloy tayo. So wala pa tayong nagpahapyaw lang tayo ng mga ginagawa sa waves dito. So ngayon binabalik ko kayo sa mga specs. Mga things lang about details about waves. Okay. Now, ang gagawin naman natin is pag-aaralan yung monochromatic plane waves. Okay? I-term by term natin definition yung mga bagay natin para hindi tayo mahirapan. Monochromatic, ibig sabihin one color. Monochroma. Okay, one color. And ibig sabihin nun, one frequency. So, omega is the same for all of them. Kasi si omega ay 2 pi f, and f is constant. Therefore, omega is constant. Alright. Then, plane waves would be waves that are single in direction. Okay? So, yung propagation lang niya, dun lang siya may dependence. Okay? So, ibig sabihin nito, kuwari meron tayong electric field at magnetic field given by this. So, waves sila, no? Electromagnetic waves na tayo. Wala silang dependence sa y at x dahil nakadepende lang sila doon sa propagation nila, which is yung z at direction mo. Okay? Okay. Wala silang So, lahat ng waves mo, bali pag dito, pag sinabi natin one direction lang, kuwari ito ay plane waves. So, mangyayari, parang magulo yun. Parang inisip ko, parang magulo siya. Anyway, point ko is, yung exponential part mo is just yung propagation mo. Okay? So, single lang yung propagation. Hindi siya nagpo-propagate between z and x, or x and y, or y and z. Isang direction lang. Okay. Okay. Now, syempre, yung electromagnetic waves mo, di ba omega is equal to kV? Therefore, if yung electromagnetic waves na yung pinag-uusapan natin, V has to be C in vacuum. Okay? So, speed of light yung C. Alright, cool ba yan? Okay, so you have that. And what else? Ayan. Kapag electromagnetic wave na tayo, ang mangyayari, transverse wave. Ibig sabihin, ayun, wala siyang dependence sa Z. Ito yung itsura nun. Yung mga transverse wave yan. Okay. Okay, and then what else can we do? Kukunin natin, gagamit na tayo ng Maxwell's equation to determine what else yung makukuha natin whenever we have EM wave. EM wave na lang pala guys para mas maikli. Okay? So, kunin natin to. Gamitin natin to solve for the del cross E, which is given by this. Okay? Ito yung curl natin nasa likod ng libro. So, sabi niya, pag transverse wave ka, wala kang Z component. So, therefore, or wala kang component dun sa wave direction ng propagation mo. Okay? So, this is 0. This is 0. Okay, so you have tingnan natin kung ano makukuha natin dito. Okay, try muna natin solve itong x-hat direction natin. So, del cross E. So, yung x part lang must be equal to negative partial of B, x part lang. Okay. So, yung del cross E mo, ano matitira dito kung x part lang? What's that? Left hand side mo na gagawin ko. Negative partial of EY partial Z. Okay? Okay. And then, ba't naglagay ako ng equal sign din? Yan. Equal sign na dito sa kanan. So, this is negative partial dx partial t. And then, I know this, how to get this. So, bababa lang yung ik. Tama ba? So, negative I, K, E, Y. Tama? And then for the right-hand side, ano yung bababa sa kanya? Ang bababa would be negative I omega. So, magiging plus to bx. So, you have this equation. Tama ba? You have this equation and then tama ba yung notation ko, guys? B naught. Arte lang. So, cancel I, negative KE, Y, omega B. Okay. Now, let's try the other one. Itong Y hat. Del cross E. Y naman yung kukunin natin. Then, partial BY. Partial BY, partial T. So, this is Y hat. And then, what's left there is I have to get the derivative of V with respect to Z. Derivative with respect to Z. Okay, EX. And then the right-hand side would be partial T. And then what's BY? Ayan. BY would be derivative na. Sige, lagyan mo natin BY. Hindi magulo. Okay, so derivative natin yung EX with respect to Z. So, matatapyasan lang yung IK. IK e raised to X, EX. Tapos ito ay bababa lang C, negative I omega T. So, this guy is I omega B1. Cancel, K, E naught X. Okay, yung E naught ay galing lang doon sa notation. Hindi ko lang sinusulat in our solutions para madali yung solutions natin. Okay, so you have this. And for the last term, guys, 0 tong dalawang to. Bakit? Dahil monochromatic plane waves nga tayo, wala silang dependence sa mag-zero out sila sa derivative with respect to x and with respect to y. Okay? Dahil z nga lang yung variables natin. Okay? So nakakalito, no? Na meron kang x and y pero hindi siya dependent doon. Okay? Ang dependence niya lang, again, pag monochromatic plane waves is yung direction of propagation, z. Doesn't depend on x, it doesn't depend on y, but it has x and y components. Dahil sila ay transverse waves. Okay? Nakakalito ba? Nakakalito? Okay, so itong mga yan, meron silang x component and y component, but they're just constants. Okay, now we can generalize these two equations to produce this guy. Okay. Okay? Napansin nyo yan, kung iayusin lang natin ng onte, b, 0x is just negative k omega e naught y. And then the other one is b naught y is k omega e naught x. And this could be generalized into this guy. This tells us that we can write down the magnetic field in terms of electric field. Okay, nice, no? Okay? So, ayun. Masusulat natin siya in terms of this. So, Z yung propagation niya, direction of propagation. Then you cross that out. You take the curl of that with respect to E. Then you produce your B. So, for an electromagnetic wave, E and B are perpendicular. Okay? Yeah. So, in phase and in perpendicular, you have this equation. So, E naught equal to CB. Okay? Or is equal to CB. So, tandaan nyo itong mga ganyan. Okay, nakapagod. Napagod ka. Okay, suppose meron tayong E na nag-point in the X direction and then B in the Y direction. Then we have these two waves. Okay, complex sila. Tandaan yan. Complex sila. Then, kita nyo dito, may direction siya X hat, but the whole thing does not depend on X hat. Dependent lang siya sa direction ng propagation, which is Z. Okay? Same thing for magnetic field B. Ito ay B naught, pero pinalitan na ng E dahil mas maganda ang tingnan. Okay? So yan, we have these two equations. And then, if you take the real part, ang mangyayari lang is babalik ka dun sa unang representation natin ng wave natin. Okay? Kasi di ba, e raised to I theta, cosine theta, plus I sine theta, kung naalala niyo yung Euler's formula. So therefore, the real part should be cosine lang. Okay? Tapos, ba't may delta biglang lumabas? Kasi meron ka pang E I delta sa A mo. Okay? So the real part of this would be cosine delta. Sama siya doon. Okay? So, yan. Yan siya. And then, the usual, okay, makikita mo lagi sa mga physics book ito. Ayan. The electromagnetic wave is this. Okay? So, E is in the X direction, Y is in the B is in the Y direction, then the propagation is with respect to Z. Okay. So, ito ay polarized in the X direction. So, yung polarization mo, nakabase siya sa direction ng electric field. May tanong sa atin, Sir, ano po yung physical meaning ng E naught at B naught? Wala. Ano lang siya? Notation. Ibig sabihin, ano siya, given siya. Okay. Ayun lang yung ano niya. Ayun lang yung silbi niya. Pwede mo siyang palitan ng E or whatever. Ito ay, ano lang, given siya kunyari. Kaya siya E naught sinasabi. Okay? So, pwede mo siyang tanggalin for convenience. Okay, so we have this guy. So, nakikita niyo yan lagi sa iba't ibang physics book. Then, meron tayong tinatawag na propagation vector. So, kasi ang daya naman na lagi natin sinasabi na z direction yung problem natin. So, we have a general form of the electromagnetic waves. Ang ingay. Sorry. Dito. Wala ako sa focus. The propagation vector is k. Okay? The direction of the propagation is r. And then n, alam natin si n would be the polarization vector. So, ang daming vector, no? Dapat pala yan. Propagation vector. So, in general, you have these kinds of waves polarized in the n hat direction and going to the r hat direction. Okay? And then, of course, you can write down B as in terms of the electric field. So, kanina Z hat to, di ba? Kasi Z hat yung direction natin. Okay? So, what is an example of the K? So, ba't naging vector wave numbers or paano namin imagine yun? Yung K mo, generally, it goes in the same direction as R. Okay? Okay? So, yung mga example ng K vector would be K. Of course, the value of K, yung omega is KV, di ba? Okay. Tapos yung direction lang niya, Z hat. Okay. Sa mga unang example natin, ito yung K vector natin. Kaya naging ganun yung natin. Naging ganun yung mga lumabas na equations natin. Okay? So this is the general form of the electromagnetic waves. Yan. So tatandaan natin lagi yan. Ngayon. So again, puro specs pa lang yung pinag-aano natin. Puro specs pa lang yung pinag-aaralan natin about EM waves. Now you have your energy. Yung UI, energy per energy density yung U, di ba? Kailangan mo silang integrate all over volume para makuha mo yung total energy. So tingnan natin to. Ano to? Paano ba to? Paano to mag-simplify when it comes to EM waves? So yung light would be would have U is equal to 1/2, and then epsilon naught E squared, then plus 1 over mu naught B squared. Okay? So B squared. However, meron tayong equation na E is equal to CB. So therefore, kunin natin square. Then we have your B squared as B squared is equal to E squared over C squared. Tama ba? Therefore, this is equal to C. Okay? So E, U, 1/2, epsilon naught, E squared. Kita nyo na kung saan ito papunta. Ang C squared ay mu naught, epsilon naught, tapos E squared. Tama? So, sinimplify ko lang to, no, guys? Yung C squared, di ba, mu naught, epsilon naught, equal siya sa 1 over C squared. Okay? So, pa-cancel yung mu naught, then, mawawala na yung 1/2. Therefore, you have your U, the energy density, as in terms of the electric field, E squared. No? Ngayon na lang matitira, E naught, E squared. It's nice. Tapos, of course, when you are given a wave, kailangan mo itong i-express as the wave. Okay? So, epsilon naught, E squared, then E squared is a wave, therefore you plug in your wave. Okay? So, this is the general form. And then the pointing vector is, okay, so computein natin yung S vector, yung pointing, no? Okay, guys, ang ganda ng pangalan ni pointing, no? Kasi yung S vector mo would actually tell you kung saan nagpo-propagate yung light mo. It points. Pointing vector. Nagtatawanan ako dito. Pero legit yan, guys. Kung saan nagpo-point yung electromagnetic wave mo, doon siya naka-point. Kaya pointing vector. Pero pangalan yung pointing, ha? Ano lang siya, magandang way of thinking lang. Okay, so S. Again, E and B are already. E and B are already. Hinat ba ito? Hinat, diba? E and B are already perpendicular. So yung curl mo is simply E times B. E times B. Okay? However, let's write down B as ito, E over C. So, E squared over C. Tama? Tapos, multiply ako ng mu naught, epsilon naught, mu naught, epsilon naught. Extra lang to. Extra factor lang. Ano ba mu naught? C. This is B squared. Okay. Para lang ma-simplify natin na maganda. This is, itong 1 over mu naught, epsilon naught is C squared. So, we have C squared, mu naught, epsilon naught, all over mu naught, C, epsilon, E squared. Okay? So, mu cancels out. Then, C cancels out. Then, we have C epsilon naught, E squared. Okay, so that is your pointing vector, which points in the direction of the propagation. So you have this C S is equal to C epsilon naught E squared. Then sabihin natin Z yung propagation ng para madali. And then, sinolve natin si U, nakita natin na yung U ay epsilon naught E squared. Okay? Therefore, S is just C U Z. Dali, di ba? Okay, so yan. Nakuha na natin. And lastly, momentum density, G. Momentum density, G, is given by this. Okay. So, hindi natin diniscuss yung chapter 8 for momentum. Pero, hindi naman namin itatanong. Sige. Ito, so definition lang siya dito. So, G will be 1 over C squared S. Okay, so ito ay momentum density. Momentum density. Okay? So, density, volume na yan. Volume yan. So, momentum per volume. Okay? So, if we are gonna write this down in terms of CU, di ba? S is equal to CU. Mangyayari, magiging 1 over CU. Which is, ano naman, mathematically madali lang to. Okay? Okay. Now, syempre ang weird, guys, ang weird na itong mga equation natin kasi yung energy is fluctuating. U is fluctuating with respect to cosine. Kasi cosine is a varying number, di ba? So, cosine squared is just 0 to 1. So, no, from time to time, naging 0 to 1 yung, 0 to 1 yung ano mo, yung factor ng energy mo. So, weird, di ba? So, hindi natin yun kailangan. Ang kailangan natin is the time average. Okay. Time average nito would be time average. Ayan. Ano sulat? Average. Yung formula nito ay 1 over period, the integral ng something. Okay, the period. Period yan. 1 over period. Okay, so ayan, something na nandun sa libro nyo yan. Pero I'll give you an intuitive way of thinking it. So, yung time average is in-average mo lang yung values basically over time. Okay? So, yung cosine mo the normal cosine. Okay, so this is 1, negative 1. Okay. So, ang time average nito, this is cosine x. Okay. So, when you have this, your values would rise and drop from 1 to negative 1 over time. Okay. So, ang average nito would be 1 minus, average nito would be 1 plus over 2. Okay, this is a for cosine only, no? Ito ay intuitive way of thinking lang. So, this is just 0. So, ang time average ng cosine would be 0. However, things change when you have cosine squared. For cosine squared, what would be the range of values? That would be, i-square mo lang yung values nito. Guys, square mo lang yung values nito. So, anong square ng negative 1? 1. Square ng 1, 1. So, ano yung minimum value niya? May 0 siya dito. Therefore, yung range of values nito ng cosine squared would be 0 to 1. Okay, so graph natin, that would be, ang itsura niya na ganito. Okay? Ay, sorry. Ayan, so ito ay 1. Ay, plus 1. Plus ito ay 0, syempre. And then the time average of this would be, nicely, 1 plus 0 divided by 2. So just 1 half. So whenever you time average sine squared and cosine squared, ang makukuha mo ay 1 half. But you can always indulge yourself with math using the time average formula, which is 1 over t, the period of the wave. Integrate mo yun with respect to your period. Okay? Okay. So you have that. So pwede mo siyang ganun kung di kayo satisfied sa pinagsasabi ko na intuitive way of thinking it. Okay? So the time average for you, kasi ang kailangan natin hindi yung fluctuating data, fluctuating values. Ang kailangan mo dito would be yung time average nito. So the time average would be, ito na, E naught squared, epsilon naught squared, E naught squared, cosine squared. So ito time average mo na lang si cosine squared and that gives us 1 half. 1 half. Nicely. Okay? Similarly, ang mangyayari sa S mo would be time averaging the cosine squared. So that's 1 half again. And then for your G, 1 half again. So you have this formula, different equations. Okay, so this itong symbol na to is time average. Time average ng U, time average ng S, time average ng G. Okay. Now, alalahanin natin kung ano si S. Si S ay this is energy density, energy flux density. So energy per sorry, may per na pala. Area per time. Okay. So basically, S is just power over area. Okay? Power over area. And that tells us one thing, this is your intensity. Okay? S is your intensity actually. Kaya mahalaga si pointing vector dahil this tells us how intense the electromagnetic wave is. Okay? So power per area yan. Okay? So nakakalito ang daming P. May meron tayong pressure mamaya. Okay, so si I ay defined as the time average of S. Okay, so as simply as that. Then pressure is force per area, tama? And force can be written down as derivative of the momentum, change in momentum per time. Kung naalala niyo pa yung dati yung physics. Okay, so we have your ang momentum mo ngayon would be somewhat related to G kasi ito ay momentum density nga lang. So how do we make it a momentum? So you suppose ito ay beam of light. Okay. Beam of light siya. Then meron siyang circular beam of light. Circular beam. Okay. So cylinder siya in essence. Okay. So this imparts a momentum na kasi di ba alam natin si GI momentum per volume. Okay, so kukuha tayo ng cylinder para mabuo yung momentum mo. Total momentum imparted. Okay? So, ito simply yung circular thing ay area lang. Okay? Yung length mo, however, varies with time kasi this moves with time. Tama? So, this length, the cylindrical length is actually V delta T. Tama? Tama. So, para mabuo yung momentum, you'd need G, the time average of G, tapos times the volume, which is A, V, actually C dapat to. But you get the point. C, delta T. Tama ba yung ginawa ko? Tignan natin. Double check ko lang, guys. Okay. AC delta T. Okay, so we have this delta P. Therefore, if you plug in that guy into this guy, delta G, time average of G, sorry, A C delta T all over A delta T. Therefore, C times the G. Okay? However, yung G mo ay defined as ayan. Ito pala yung sagot, sorry. C. Okay? So, yung time average of G is this. Times C, so mawawala lang yung C. So, 1/2 epsilon naught, E naught squared. And that is this guy, time divided by C. Okay? So, ayan. Ayan. So, ito ay pressure na nararamdaman ng isang surface of area A when it is bombarded with light. Okay? Amazing na. So, may pressure na nararamdaman dun. So, kung naaalala niyo yung Nobel Prize in Physics in 2018, if you have a light source, you can actually use them as tweezers. Okay? So, kaya mong bumuhat ng particle gamit yung light. Dahil nag-i-impart ng momentum yung light. So, kaya niyang bumuhat. Okay? Amazing, di ba? Haba pa ng lesson natin. Kaya ba? Kaya to. Okay. Now, let's look at EM waves in linear media. Kasi kanina puro vacuum tayo, pang dali yung buhay natin. So, letter C lang mga bagay-bagay. Okay, so whenever we are in a homogeneous matter where there are no free charges and or free current, ano ibig sabihin ng homogeneous? So hindi siya nagpapalit ng value or nagpapalit ng medium. Okay, so isang medium lang siya kung saan walang free charges and walang current. Therefore, your Maxwell's equation would reduce to these guys. Okay, parang familiar siya, no? Parang ito yung sinolve natin for the yung speed ng light. Okay? So actually, that is the case. Ito nga rin yun. However, look at this. So yung material mo would have mu and epsilon instead of mu naught and epsilon naught. Okay, so when you take the curl of these guys and etc., you'll arrive with wave equation that gives you the speed, this guy. Okay? And then if we're gonna write down this velocity in terms of the index of refraction, n, tapos with respect to c, which is the speed of light, then you can have this by defining n to be this. Okay? Okay, so this is your index of refraction with respect to the permittivity and permeability of the material. However, in usual cases, yung mu mo ay approximately equal to mu naught. Therefore, magiging ganito na lang siya. Usual case to, maraming material na magkamukha lang yung mu niya at mu naught. Kasi maliit na value yung mu. Okay? So you can actually approximate your index of refraction in terms of the relative permittivity. Okay? So ang relative permittivity ay ito rin. Okay? Ayun lang. Simplify lang siya. Ito rin yun. Okay? And everything follows. No? Everything follows. The energy mo, energy density, would be replaced by the epsilon and mu. The pointing vector would have mu instead. Tapos intensity mo would have epsilon and v instead. Kasi mas mabagal yung light in your medium. Okay, so different na siya. Hindi na siya C. In vacuum, C siya kasi mabilis na mabilis siya. However, this guy, mas mahina na siya ngayon. Mas mabagal na siya ngayon. Okay? So, in essence, ganun lang yung nangyayari. No? Whenever you are in a linear medium. Okay. Lagi ko sinasabi na linear medium, no? So, in other case kasi, pag hindi linear yung medium mo, lumalakas yung light. Ibig ko sabihin, nagbabago yung frequency and so on and so forth. So, the equations changes. Equations change. Okay, equations change. And things might get more complicated. Pero, hindi natin kailangan yun. Okay? So, ayan. Papalitan mo lang si epsilon naught tsaka mu naught. Kuha ba yun? Okay. Now, ito na talaga. Yung kailangan natin. Mag-solve na tayo for reals. Okay? So, ang babalikan natin, yung reflection and transmission. Kaso ngayon, normal yung incidence mo. Ibig sabihin nun, meron kang boundary. So, medium 1, medium 2. Then your electromagnetic wave collides head-on to your surface, to your boundary with the right angle. So normal siya. Ibig sabihin perpendicular with your boundary surface. Okay? Okay. So now things get more complicated. Ngayon, maglalatag tayo ulit ngayon ng equations. Okay? So you have 3 sets ng equation. You have those for that incident, reflected, and then transmitted. Okay? Pansinin nyo, okay? Ganun pa rin naman. Negative, negative, dahil papunta sa left. Ito ay z hat ito, guys. Ano? Z hat. Okay, by right-hand rule, this is exact. Okay. So, ayan. I-assume natin na yung wave natin is polarized in the x direction para madali. Pwede naman natin i-rotate yung system para maging y yung polarization, pero wag natin kahirapan sarili natin. Pwede mo naman i-rotate to, pero ayun na. Doon na lang tayo sa intuitive sa atin. Okay? So ayan, very straightforward naman. Alam naman natin na E would be V, B. Okay? So, kanina vacuum kasi, kaya naging E is equal to C, B. Ngayon, meron ka ng specific velocity whenever you're in some kind of medium. Okay? So, you have V1 for those velocities in the first medium. And the second would be, the second subscript, 2, would be for the second medium. So, gets naman lahat to, no? Gets naman lahat. Okay. Z hat direction, and etc. So, naglatag lang tayo ng general form ng mga waves natin. So, ano itsura niyan? So, ito itsura niya in 3D, no? Okay, so may interface ka which lies in the XY plane. Okay? Tapos Z, direction ng mga bagay-bagay mo. Okay. So B1 points at us. BI pala, BI. Okay, so nakatutok sa atin to. Nakatutok din sa atin si BT. Then into the page would be BR. Okay. So parang hindi nakakalito. Okay? Now, meron tayong boundary conditions, of course. The boundary conditions now changes. So you have your electromagnetic boundary conditions, which are these guys. Okay, so ano to ito ay corresponding to your Maxwell's equation. So yung una natin would be the Gauss's law. Pangalawa, yun, palang pangalan. Pang-apat, Ampere's law. Pangatlo would be Faraday's law. Okay. Tingnan natin. Yung boundary condition 1, meron ba siyang ibibigay sa atin? Oops, wala. Kasi lahat ng I mo parallel to the interface. So, pataas sila or pababa, pero walang pababa. So, pataas lang lahat. Therefore, walang ibibigay itong bagay na to kasi walang nakatutok dito. Okay? Walang perpendicular to this boundary condition. To this interface, I mean. Okay? Then, B1 and B2, what does this give us? Similarly, ganun din si B1 at B2. B1 at B2. So lahat ng B mo is parallel again to your interface. Therefore, wala din sila ambag. Yung mga may ambag lang would be these guys. Kasi sabi nga natin, parallel sila to your interface. Okay? Okay. So at Z is equal to 0, what happens? Sa boundary condition 3 mo, dapat satisfied ito. So pag pinlagin natin si Z0, magka-cancel na lang yung mga exponential pag pinagsama-sama natin silang lahat. So you have this, again, very, mula kanina, ganito rin yung nangyari, di ba? Kasi may mga e raised to negative I omega t dito, tapos magka-cancel silang tatlo. Okay, so wala yan. Boundary condition number 4, what does this tell us? What does this tell us? I-express natin si B as a function of your tawag dito, electric field. Okay. Intuitive naman itong right hand side, di ba? Kasi E is equal to V B. So B will be simply E over V. Now, for the left hand side, however, meron kang negative sign dito dahil opposite direction siya. Kuha ba yan? Kasi pag ni-reflect mo na-reflect back na yung wave mo para sa reflected, yung direction nun by the right hand rule, magpo-point into the page yung beam mo, so dapat negative siya. Okay, negative y hat, pointing into the page. Okay, so we have that. So dito yung nagre-reflect, no? Dito yung nagre-reflect. Okay, kita natin yun. Therefore, I can rearrange this. I can do this, factor out V1, 1 over V1, then your right-hand side would be mu1, V1, mu2, V2. Then E not T. Okay. Have this. Then you can write this down as beta. Let's write down as beta is equal to mu1, V1, mu2, V2. Okay? Okay. Ang goal natin is to get the reflection and transmission. Okay? So whenever, kapag you have these two equations, sulat natin yung dalawang equation natin, E naught I plus E naught R is equal to E naught T. Tapos yung pangalawang equation natin will be E naught I minus E naught R. Then, beta, E naught E. Okay? So, ayun yung dalawang equation natin. So, pinopya ko lang yung una. Yun pa rin yun. Then, pangalawa, sinimplify lang natin by writing down beta. Okay? So, si beta ay mu1 V1 over mu2 V2. You have this. Okay? So, sige, simplify mo na lang to. Madali lang to, di ba? Para kunin natin si transmission. Madali lang. Cancel mo agad si reflected by adding the two equations. So, 1 plus beta. Okay, so solving for E naught T gives you this. Okay, in complex notation pa rin yun. And so on and so forth. Okay, si beta ito, then you can write them down as in terms of index of refraction, which is easy kasi B is equal to C and so B1 equal to and so on and so forth. Okay, yan. So, hindi ko na-solve to Nakita nyo naman na kung paano sinasolve tong isa. Kasi, ano mo lang yan, systems of linear equation. So, yeah, for the other one, for this guy, isusubtract mo naman tong dalawang ito. Joke na yun pala pwedeng gawin kasi magka-cancel tong ano. Okay? Cancel doon. So, pa-plug in mo tong second equation to this third. Or yung first equation to the second one. And you'll get this equation. Okay? You'll get this equation. Now, ginako lang yung notes ko. Okay. Now, di ba sabi ko nga, for most medium, mu1 is approximately equal to mu2. Okay, when you have that, when you have this assumption, then beta becomes V1 over V2. Then this guy simplifies to this one. Okay? And then if it is in phase, if E naught I and E naught are in phase, then ito yung makukuha mo. But if they are not in phase, ang makukuha mo ay V1 minus V2. Diba? Kanina, di ba, nakapansin natin ito, nag-flip siya ng signs. Pero, in essence, kinukuha mo lang yung absolute difference between the two. So you can actually generalize this down as an absolute value. Okay? So kahit na lumagpas siya, ganun pa rin makukuha mo naman, di ba? Okay? Alright. Wait lang Okay. Sorry. Going back. We have this relations. And then, pwede mo na ngayon siya i-write down as in terms of your index of refraction. Okay? We have this. Now, ang mahalaga sa atin would be the R and T coefficient. So, reflection coefficient and transmission coefficient. Okay? So, to do that, you'll have to write things down in terms of intensity. The intensity the intensity would be defined by this, tulad kanina, and you'll have three intensities, II, IR, and IB. T. Okay? You have that. Tapos, the R coefficient would be, the R coefficient is defined as this. IR over the relative intensity between the reflected and the incident light. Okay? Okay, okay. So guys, kung nagwa-wonder kayo, baka nagwa-wonder kayo. Mula complex, lumipat tayo sa tawag dito, sa real part by considering the cases na yung meron kang EI delta for the phase, EI delta I. Okay? And sinabi nga natin na yung difference lang naman between the in phase and out of phase na cases would be the switching of the terms here. Okay? Pero you can generalize them down as an absolute value. Okay? So ito, okay. After this, you'll need to compute for the R and T coefficients. So for R, i-divide mo lang. I-divide mo lang yung dalawang intensities mo. So the intensities would be given as 1/2. Compute natin. Epsilon 1, V1, V0 squared, IR pala, R squared, tapos divided by 1/2, epsilon 2, V2, 1 pala, sorry. 1 pa rin to kasi incident siya, then V1 pa rin kasi incident siya, then ang magbabago lang is okay, we have this. Then, syempre magka-cancel lang yung mga extra terms. This would actually be equal to the reflected and the incident, divide mo tapos square. Ito lang natira, di ba? Okay, yun natira. Therefore, dali lang nun. Yun lang din. Yun lang din yung makukuha mo. N1 minus N2 over N1 plus N2. Okay? And then, yung komplikado lang is yung T, transmission coefficient mo. So, IT naman, basically, papalitan mo lang ito ng 2, T, and then you'll have this extra terms. E2, B2, epsilon 2, B2, epsilon 1, B1. Then, you divide this guy. Okay? So, itong factor na to, napakadali lang makuha, which is this guy. Okay? So, yung compute mo na lang is yung ito. Okay? And it turns out, magre-reduce siya sa gantong equation. Okay. Nawala daw ako. Saan ako nawala? Sorry. Hello? Okay, sabi ko saan ako naputol. Hello, 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 hello. Okay. Reply kayo sa chat. Sorry. Naputol ba ako? Am I here now? Thumbs up ngayon kung nandito ako. Hello, hello. Sorry. Hello, sorry. Saan ako naputol? Oh my God. Very sorry. Hello, hello. Sorry, saan ako naputol? Malayo yun malayo. Ilang minutes ako nawala, sorry. Na-discuss ko na ba to? Okay, sorry. Nawala pala ako. About 5 minutes. Sir, dun. Okay, nakikita nyo na ba yung screen ko? Sorry. Okay, kita na. Natapos na to? Natapos na to ba to? Checkmark na kung natapos na to. Okay, hindi pa. Okay. Eto, natapos na ba to? Checkmark kayo kung tapos na to. Dito pa lang ako na ano, oh my God, ang layo ng pinagsasabi ko. Dito pa lang ako, sorry. Dito pa lang ako. Doon po sa mu1 is equal to mu2. Dito, okay. So sinabi ko na at most materials, yung mu1 is equal to mu2, tama ba? Ayun yung huli kong ano. Tama ba? Dun ba? Okay, so at most materials, guys, sorry. Most materials, ang mu1 and mu2 mo ay equal lang. So therefore, masisimplify mo yung equation na to, yung beta mo, in terms of the velocities. Okay? So, ito na lang matitira sa beta mo, V1 over V2, then you can expand things to obtain this equation. Okay? And then this is a complex wave, so lipat tayo sa real kasi ayun yung kailangan natin. However, doing that, ang kailangan mo would be delta R, yung phase constant, and delta I. Okay. Meron tayong dalawang cases, di ba, kanina? Meron tayong in phase and out of phase. Diba? Pag in phase, V2 is greater than V1. Therefore, normal yung subtraction mo. However, whenever you're out of phase siya, magpapalit lang to ng signs. Okay? So, ang mahalaga, kinukuha mo lang yung difference between V2 and V1. So, in general, you can generalize that further into V2 minus V1. Tapos, i-absolute value mo na lang. Okay? Para sa real part. And then, of course, from the velocities, you can go into the indices of refraction, which is detailed down here. Okay? Sorry. Now, ang kailangan natin would be the R and T coefficients, which are the reflection and transmission coefficients. To do that, ang kailangan mo is yung intensity. And then yung intensity mo magiging tatlo din dahil meron ka incident, transmitted, and reflected. Okay? So for R, yung definition ng R would be the relative intensity between reflected and incident. And then for T would be the transmitted over the incident. Okay, so doing this, magka-cancel lang yung Yung epsilon mo tsaka V mo kasi at the medium 1, parehas lang yung E mo tsaka yung V mo. Tama ba? Kasi parehas to nasa medium 1, di ba? So parehas lang din dun yung mga properties ng medium. Okay? So V2 V2. I mean yung V mo would be same lang din for that medium. Therefore, matitira na lang is yung ito. And this is very easy kasi kung titingnan mo, ito lang yun. Squared. Diba? Okay. For the transmission coefficient, magkaiba na yung E2 mo tsaka V2 mo, so hindi sila nag-cancel, pero nag-cancel yung 1/2. So you have this. And then, madali nang tukunin kasi nakuha mo na to. Okay? So mag-i-square yan. And then, you can find out that mas simplify mo yung numerator as this by simplifying this constants. Okay? So si V1, related siya with your index of refraction as C over N1. Okay? Okay, so you have that. Mansinin nyo guys na kapag inad mo si R and si T, di ba? Ito ay magiging denominator niya N1 plus N2 squared. Tapos yung numerator would be this guy. Pag in-expand mo to, magkakaroon siya ng minus 2 and 1 and 2. Tapos i-add mo siya dito, ang matitira plus n1 n2. Tapos may n1 squared ka. Tapos may n2 squared ka. And what is this? This whole thing cancels out. Kasi magiging n1 plus n2 squared yung numerator. And it's amazing, di ba, na this is 1. That makes sense. Na walang nagli-leak out somewhere. So kung wala kang transmitted, lahat ng reflected mo is 1. Di ba? So yung T mo magiging 0. So wala kang transmitted, then therefore, lahat ng matitira na lang would be reflected. Okay? Okay, that's nice. Okay guys, 6 o'clock na, pero I would just like to continue a bit kung okay lang sa inyo. I mean, go lang kung mag-leave na kayo. It's okay. Para lang ma-record dito. So, tutuloy pa rin ako kahit wala kayo. Para lang ma-i-upload ko na rin. Okay? So sa mga gusto mag-stay, thank you. Kung sa mga kailangan na umalis, go lang. Para lang ma-record na to. Okay? Para next Friday, pwede tayong mag-review or continue with another lesson. Okay? Now, itong unang ginawa natin is reflection and transmission at normal. Therefore, yung collision niya dun sa surface mo is head-on. Bale, perpendicular yung collision niya. So now let's look at the more general case. That is yung oblique yung incidence mo. Okay? Ibig sabihin, ayan, meron tayong tatlong propagation of light, yung Ki, Kr, and Kt. So tumama siya at some angle, incident angle theta I, then reflect siya with an angle theta r, then yung transmitted would be theta t. Yung angle niya with respect to the line of propagation. Okay? So again, maglalatag ka muna. First step is maglalatag ka ng tatlong sets of equation that defines your waves. Okay? So for Ki, meron kang dalawang equation that would be your electric and the magnetic field. Okay? Then, reflected, transmitted, and makapansin nyo, hindi na siya Kz. K.R na siya. Okay? So, lalo nagiging mas mahirap yung mga bagay-bagay. Etong right-hand side mo, sa magnetic field mo, sinulat na lang siya as this dahil mas maganda yung notation na to. Mas malinis. Okay? And then, one thing about here is constant yung omega. Okay. Constant yung omega dahil yung omega would define your light. Okay, so omega is constant, therefore, omega must be equal to K1 V1, must be equal to KR V1, K2 V2. Okay, lahat sila is equal to omega. And then you can further simplify this as something like this. Okay, pwede mo divide by V1, and you'd see that Ki is equal to Kr. Okay, differ lang si Kt. Okay, now we do the boundary conditions tells us that yung continuous dapat yung wave mo. Okay? At z is equal to 0 at the interface. Okay? So with that, let's write this equation down. So yung mga nasa parentheses, for brevity lang yan, pwede mo lagay dyan yung E. Okay, in essence, ganito yung itsura ng equations mo. Okay? Ganyan yung itsura ng equations mo. Now, that is at z is equal to 0. Kung mapapansin nyo, they all have to emanate at some point here, at the point of interaction with the surface. Hindi na po negative, sir, yung sa may reflected. Ito. Okay, guys. May tanong sa atin. Hindi ba ito dapat negative, sir? Nakaloob na sa kanya yung negative. Okay? So, R kasi is, would differ for this. Okay? So, nakaloob sa kanya yung negative Z. Okay, good question. Good question. Nandun sa loob ng R. Okay? Okay. Okay. So, I want to convince you guys that when we are in Z is equal to 0 at the interface, okay, I want to convince you that everything of this would be equal. Okay? Everything here is equal. Okay. Paano ba natin i-imagine ito na equal siya? At Z is equal to 0 lang naman, di ba? So at other values of Z, this guy is different for iba-iba sila. Okay? Iba-iba sila at different whenever Z is not is equal to 0. Okay? Okay. Now, I want to convince you that this is equal at this point. Kasi equal sila dahil they're all emanating from one point. Okay. So, ang nagbabago actually dyan is Z. Yung direction of propagation mo. Okay? So, at Z is equal to 0, actually, yung Z mo, papunta dito yung isa pa ganun. And then, the other one is pa ganito. Okay? So, this guy is positive, negative. Okay. Pansinin niyo sa X. Si X ay positive lang lahat. Positive for X, positive for X, positive for Y. Di ba? Lahat sila pataas. So, lahat sila ay positive X. So, in essence, si K.R, nagne-negative yung part ng Z niya kapag pag magre-reflect na siya. Okay? Magre-reflect na siya, magpapalit na yung sign niya. However, we are looking at Z is equal to 0. So that thing, hindi natin siya i-consider. Di ba? Kasi Z is equal to 0 naman eh. So yung Z component ng K.R, Z, is actually 0. K.R at X is actually same for all. Kasi they are in one point of X. Okay? So they are in one point of X. So kahit hindi yan X equal to 0, they are still in one point of X. Si Y, sir, si Y. Walang Y dito kasi pinesto natin yung mga light natin on the XZ plane or in the plane of incidence. Sir, parang daya naman na iniwan mo si Y. Okay, sige, huwag natin kuwari arbitrary yung galaw ng mga bagay-bagay. Therefore, yung K.R would be This guys. Okay? So, CX, KI, X. So, X part ni, pag kinuha mo yung K dot R, meron kang dalawang component that would be X and Y. So, for the X, yung kakapit lang sa kanya, yung X component ni KI. For the Y, yung kakapit lang sa kanya, yung Y component ni KI, and so on and so forth. Okay? However, if we let X to be 0, kasi dapat valid for all points to, di ba? Valid for all points, valid everywhere. Everywhere in the z-axis, syempre. Okay? So, dapat mag-hold tong equation mo. So, kapag sinet natin na x equal to 0, ang lalabas would be, cancel to. And therefore, cancel yung y, y, y. So, yung equality nila would be actually on the y-axis. And if we're gonna let y is equal to 0 naman, mapansin natin na yung relationship nila KR, KI, KT ay lahat nasa isang direction lang. Okay? So therefore, we can actually set yung plane of incidence natin in one. So pwede natin lahat ilagay yung interaction natin in one plane. Okay? So kung wari meron kang wave of light, ganun, natama siya sa boundary mo, may matatransmit siya. So yung reflected dapat in the same plane nitong in the same plane nitong ay kuwari ito ay z, ito ay x. So dapat lahat sila nasa xz plane. So hindi pwedeng mangyari guys na pag dumaan to, may tumamang light, papasok sa loob into the page yung reflected, as out of the page yung in the same plane yung same plane yung transmitted. So hindi pwedeng mangyari yun, no? So lahat sila dapat nasa isang plane. Okay, and tawag doon sa plane na yun is the plane of incidence. Okay. So in this case, ang plane of incidence natin is xz. Okay ba yun? Okay. Now, pili na lang tayo ng pili na lang tayo ng kakalabanin natin. So, ang gusto ko, si y is equal to 0 na lang. Set na lang natin ng y is equal to 0. Rotate natin yung system natin such that yung plane of incidence, nandun lahat ng vectors ko. Okay, nandun lahat ng light ko. Okay, so yan. Ito yung dinowing natin. Lahat sila nasa xz. Okay. And this implies, itong tatlong equation natin ito, that ki, yung x part ni ki is just, projection nito, in the x projection nito, would be sine, di ba? Sine nitong theta. And yung x projection nito would be given by the sine. And also this one, by the sine. Therefore, ki sine theta I must be equal to kr sine theta r and must be equal to kt sine theta t. Now, what have we said about, tingnan natin itong dalawang to. What have we said about ki and kr? Ki and kr is indeed equal. Therefore, cancels out. There, para maging equal sine theta I with sine theta r, this means that theta I must be equal to theta r. And what is this? This is your law of reflection. Law of reflection. Okay? So may mathematical basis to guys. Hindi lang siya dapat equal yung incidence sa reflected. Okay, so ito. Then let's look at the other one. So ki sine theta I must be equal to kt sine theta t. From this, ayun, nakita nyo na. Ano yung definition natin ng k? Pwede natin siya isulat in terms of the di ba? In terms of your ayan. Okay? So pwede natin i-divide yung ki by kt, and we have n1 over n2. Okay, ito. Okay, yan. Therefore, if we have that, Ki over kt is just n1 over n2. Ki over kt sine theta I is just n1 over n2 I. n2 sine theta I must be equal to sine theta. Ito, na carried away lang ako. Okay, what is this? This is your Snell's law. Yan. Okay, yan sila. So whenever you have waves passing through a surface, mapansin nyo na ayan, sinusundan nila yung Snell's law. Ayun, din natin na-derive yung Snell's law tsaka yung law of reflection. Okay? Okay, sorry, nandito pa ba ako? Thumbs up kayo kung nandito. No, mamaya wala na naman ako. Sorry. Okay, thank you. So, hindi ko alam na nag-fluctuate na pala yung internet ko. Okay, now, tuloy tayo sa mga boundary conditions that would govern your equations. Okay, so yun, the left-hand side would be the Maxwell's equations, the boundary conditions from the Maxwell's equations, and the right-hand side would be the equations arising from those boundary conditions. So, ito, 1:1, 2:2, 3:3, 4:4, okay? Okay, so pansinin nyo guys, merong, okay. So, lahat ng perpendicular sa surface mo would be, of course, ito pala. Okay, so, from this, lahat ng perpendicular dito, syempre Z lang yun. You have Z. And same goes for B. Lahat ng perpendicular would be on the Z. Then, lahat ng parallel would be two parts, X and Y. Okay, so lahat ng parallel dito sa surface mo would be X and Y. So, yung Y dito is nakapoint sa atin, ha? Okay. Okay. So, now we assume that the polarization of light, pwede naman natin hindi assume yan, pero para madali, yung polarization is in the XZ plane. Okay, ibig sabihin nun, si E, nakahiga siya sa XZ plane. Okay, so si BR dito, nakatutok sa atin. Si BR dito, nakatutok sa atin. Si BI, nakatutok sa atin. And then, si BR pala nakalusot sa loob. Okay, nakalusot siya sa loob into the page si BR. Si BI nakatutok sa atin. And then si BT nakatutok din sa atin. Okay, so that's how you imagine this. And then you apply this guys. Okay? Kapag inassume natin na yung polarization is in the XZ plane, therefore walang B na may component na Z, di ba? So lahat sila nakatutok sa Y. Wala din siyang X. Diba? Kasi into the page and out of the page lang siya. Okay? Si E, meron siyang Z component at X component pero wala siyang Y component. Okay, so let's do this. So for the first one, this guy, meron component si Z, therefore, kunin muna natin yung gawin natin to. Okay, itong unang equation, ibig sabihin lahat ng perpendicular with your okay, tama. Lahat ng perpendicular with your surface. So guys, pansinin nyo to Okay. Pag tinaas ko tong vector na to dito, di ba ang itsura niya pa ganito? Okay. Okay. So, kuwari, nilatag ko siya sa Z-axis. Kuwari, yan. Ayan yan. Okay. Ay, nakalito. Okay. Yan. Tapos, binring down ko siya with an angle theta, theta I. Therefore, itong EI ko, saan yung angle niya? This is yung angle niya. Okay? So, ito, yung angle niya with respect to the horizontal is actually theta I. Ay, vertical pala. Sorry. Vertical. Therefore, yung perpendicular component ng EI to the surface is the sine of this. So therefore, pag kinuha mo yung sine nito, makukuha mo yung projection on this part. Okay, so that's negative. So here, EI, sine theta I, so that's negative dahil to the left. Here, ang makukuha mo would be to the right. And on the right-hand side, ang makukuha mo is negative again. Okay? Okay, so yun. Kaya siya naging negative sa libro. Baka namalito kayo sa libro pag inulit niyo yung pinagbinasa niyo siya ulit. Okay? So si 2, walang mangyayari dahil wala kang z component ni B. So number 3, ano mangyayari? Kukunin mo lang yung parallel with your surface. And napakadali nun kasi kunin mo lang yung cosine parts. Okay? And lahat sila pointing up, so lahat positive. Positive x. Okay, so cosine, cosine, cosine. You have this equation. Lastly, so number 4. Okay, number 4 would be, dali lang din. Kailangan mo lang kunin would be yung y, yung mga y, di ba, nakatutok sa atin at nakatutok paloob ng papel. So towards us, and how do you compute for that? Okay, so i-add mo lang daw sila. So si B not R is into the page, kaya siya negative. Negative siya dito. And positive yung B not T tsaka B not I kasi nakatutok siya sa atin. Okay, so yung nakatutok sa atin is positive y hat direction. Yung nakatutok pa loob is negative y hat. So kaya siya may negative sign doon and positive yung dalawa. Okay, so simplify ko lang to. So guys, kung gusto niyo nang mag-go, okay lang. Nire-record ko lang siya. I minus E not R. Okay. Then mu not mu not 1. Mu 1, sorry. Sabaw na. Mu 2 V2. E not E. So sulat ulit natin as beta. Okay? And this guy, actually, sign, magiging kakalabasan nito. Multiply ko lahat by negative sign, no? So magne-negative itong pangalawang term ko dito. Therefore, sin theta I and sin theta R is equal. Kasi dahil sa law of reflection, therefore I have minus E naught R. Hindi ko muna sinusulat yung mga tilde, guys, para mas madali buhay natin. And then, must be equal to epsilon 2 divided by epsilon 1 E naught T sin theta T over sin theta I. Okay? So si R wala na. Kasi pinalitan ko lang siya ng sin theta I. Tapos dinivide ko. Okay, makes sense naman, di ba, na ganito siya. And this guy would actually result to your Snell's law. So this is N1 over N2. Tama, di ba? So, mapalitan lang to ng N1 over N2. Okay, so burahin na natin to. N1 over N2. Okay, so you have this. Guys, kung titry nyo, ikitry nyo siya in your own time. I'm sorry. Bumalik siya. In your own time, susubukan nyo na yung E2 N1 is equal to E1 N2 is equal to mu1 V1 mu2 V2. Okay? Equal lang sila. Therefore, this is just also beta. Okay, so these two equations are equal. Sir, mas gamit po ba in application ang N? Kaysa, yes. Ang N mas madali siyang gamitin. Okay? Kasi sa material mo, may index of refraction ka na agad. Kaya ayaw natin iniiwasang gamitin yung V. Kasi mahirap mag-measure ka pa ng speed of light sa loob ng material, which is impractical. So you just use the index of refraction, which is dependent on the properties of the material. Okay? And this guy, again, same lang yung theta I mo at theta R. Therefore, you have the equation, this guy. Okay? So si alpha I cosine theta naught, theta T over cosine theta I. Sorry, natasabaw na ako. Ayan. Okay. So this is the two equations na nabuo na natin din sa tatlong to. Okay, so yung dalawa dito nag-simplify lang into this. Then the cosines would be this. And of course, ano nang gagawin natin dito pag sasamahin mo na sila? Pag pinagsama mo na sila, ang lalabas would be this guy. Okay, this is the Fresnel equation. And mapapansin mo na parang kamukha niya yung mga previous result. Kasi ang previous result is 1 minus beta, 1 plus beta. Then the other one is 2 over 1 plus beta. Okay, so kailan magiging 1 yung alpha mo? Kapag head-on collision ka, di ba? So kapag equal yung theta I sa theta T. So ito yung pag normal incidence ka, yung kanina, equal lang tong dalawang to, so it reduces to 1. Okay? It reduces to 1. Then we can write alpha purely in terms of theta I. So, okay. So, yung una, cosine theta, yung numerator, t, di ba? Cosine theta I. We know cosine squared plus sine squared is equal to 1. Okay? Therefore, yung numerator mo, pwede mo siyang isulat as this guy. Okay? Square root ng 1 minus sine squared theta t. Then, yung sine squared theta t, may Snell's law tayo. So, therefore, you can write it down as in terms of theta I. Okay. That's nice, di ba? However, a special thing occurs when beta is actually equal to alpha. And what happens to this is that yung wala kang nare-reflect, there is nothing to be reflected dahil beta is equal to A. And what happens is that makukuha mo yung Brewster's angle. So yung Brewster's angle is yung lahat ng incident mo would be reflected onto the surface. Okay, so walang nare-reflect amazingly. So how do we do that? You can write this down as so balik tayo dito sa alpha, no? So alpha, sulat ko siya as alpha squared para 1 minus n1 over n2 squared sine squared theta I. So sulat natin si theta I as theta B dahil Brewster's angle na itong kinukuha natin. Okay? Theta B. And then, mas squared din yung baba, cosine squared theta B. Cosine squared can then be written as simply n2 squared sine squared theta B. And then, this is simply 1 minus sine squared. Di ba? Theta B. Then, you can factor, try to get sine squared onto the left-hand side. Then, you can actually arrive with this equation. Okay? So, makakuha mo itong equation na to pag in-isolate mo si sine squared. Then, si alpha mo, since alpha is equal to beta, this is beta squared. Okay, so mapoproduce mo to. Hindi na natin papakita dahil this is algebra. You can do that, guys. Magaling na kayo dyan. Okay? Then again, for most materials, beta is mu1 v1, mu2 v2, and mu1 and 2, mu1 and 2, mu2 and 1, For most materials, mu1 is approximately equal to mu2. Okay, pa-clarify po yung si alpha. Si alpha ay cosine theta t over cosine theta I. So, nakuha siya dito. Okay, so dinivide lang by cosine theta I. So, si theta I at theta R ay equal lang. So, the left-hand side would remain like this. And E naught t cosine theta t over cosine theta I. Okay, so this entity is pinadali siya ng alpha. Okay, so just write down things for brevity, for convenience lang. Okay, so that's yung alpha mo. Okay, now for most materials, mu1 is equal to mu2. Therefore, beta becomes n2 over n1. Beta is equal to n2. Yes, n2 over n1. Therefore, we can simplify this guy. Baka maguluhan kayo kay Griffith, bila siyang tumalon dito. Beta squared, this is 1 over beta squared minus beta squared. Then I multiply everything by beta squared sa numerator and denominator. Beta squared, beta squared. Okay. 1 minus beta squared. And this is... Okay, so pagsasamahin ko yung denominator value. Yun yung goal ko. This is 1. And then makakancel yung beta squared here. So this is 1 also. Minus beta to the 4. Okay. And then this guy, beta squared. I can factor it out nicely. 1 minus beta squared. Okay, so tumalon si Griffiths dito, baka maguluhan kayo. Paano nyo na-obtain yung mga bagay-bagay. So sine squared theta b is actually equal to beta squared over 1 plus beta squared. And then sine theta, syempre, square root lang natin. Beta over square root ng 1 over beta squared. Okay? Okay, si sine ay, ito ay opposite over hypotenuse. So, drawing tayo, kuwari meron tayong right triangle, meron kang angle theta, theta b. So, therefore, yung sine theta b, if it is opposite over hypotenuse, this tells us that this is beta, and the hypotenuse would be square root of 1 plus beta squared. Therefore, the missing side must be 1 para pag kinuha mo yung hypotenuse, makuha mo yung 1 plus b squared. Therefore, I can relate this guy by tangent, theta beta, theta b, oh my god, kaya pa ba? Opposite over adjacent, so that's beta na lang. And this is n2 over n1, tama ba? n2 over n1, okay. If makalapit lang si mu. Okay, so that is your Brewster's angle. So whenever you're given indices of refraction n1 and 2, then you can have makukompute mo si theta b gamit nito. Okay, at that angle, lulusot lang lahat ng incident light mo. Na-transmit siya lahat. So ito yung mga nangyayari dun sa mga mirror mga glass panes na walang reflection. Kaya nababangga yung mga tao. Okay? And then, of course, para makuha yung R and T coefficients, you need tatlong I, IR, and IT. And this would amount to the reflection coefficients being this guys. Okay? So, hindi natin gagawin. Madali lang naman yan, di ba? Ayan. So, yung mga reflection and transmission coefficient, dapat pag inad mo yan, evident naman siya. No? Pag inad mo to, makukuha mo yung R plus T is equal to 1. So, dapat laging ganyan. No? Pag mag-check ka ng reflection and transmission coefficient mo, dapat mag-equal siya sa 1. Okay, in summary, paulit-ulit lang ginawa natin. You write down the general form of the waves. You apply the continuity on the boundary. Kailangan tuloy-tuloy lang yung waves. Then yung tree lang yung nagbabago. Yung tree lang yung nagbabago kasi nagbabago yung boundary conditions. Electromagnetic boundary conditions. So, it depende to sa Maxwell's equations nung system mo. In some systems, meron kang conductor, say conductor. So, si mu naught J, magbabago. Magiging mu naught sigma E. Okay? So, may mga ganung bagay. Pag conductor yung dadaanan mo. And then you solve for the real parts. You isolate the real parts. Then, you get the RNT coefficients. Yung RNT coefficients, kailangan mo lang tatlong I. Okay, so paulit-ulit lang to. Ganito lang yung ginagawa natin sa waves. Okay ba yan? Then, the prob set would be this guy. Then, may bonus prob set tayo. No? Bonus prob set will be added again to your score sa pure number. Hindi siya may scale. Okay? So, ito ay may equation na binigay. So, gagamitin nyo itong equation. Okay? You just explain how this equation comes into life. You don't have to prove the equation given. Okay, so itong prob set nyo, circularly polarized yung kailangan nyo hanapin. Sayang may dala akong polarizing filter. Tapos hindi siya gumagana sa source of light ko. Basically, itong filter na to, pag inikot ko siya, napakita ko to sa dating class ko yun. Mangingitim siya. So, walang magpa-pass through na light. So, ayun yung ibig sabihin ng polarization ng mga light. No? Kuwari, nakapolarize siya vertically, hindi siya papasok sa horizontal na slits. Okay? So, magva-vanish siya. Amazingly. Okay, thank you for staying. Sorry, ang tagal na natin nag-stay. Thank you sa nag-stay. So, ilan nag-stay plus bigyan ko kayo ng plus 2. Yan. Bigyan ko kayo ng plus 2. Wait lang. Sulat ko yung mga pangalan niyo. Wait lang So, sulat ko lang yung... Okay. Stop share na natin.